So I want to take a minute to talk about how the Earth's layers are defined, because I believe that this is actually a really important idea. So as you read, that Earth's layers are going to be defined by seismic. So what is seismic? Well, seismic are the waves that are generated during an earthquake. So when the Earth shakes, we're going to learn, especially when we get to the earthquake chapter, that there are 4 different kinds of waves that are produced. Now, you've all experienced seismic at some point, especially because we live in Louisiana. So if you've ever been in your house and a UPS truck has gone by and everything in your house is kind of shook, that's seismic. So we can actually use this seismic to define the layers. So let's just talk very briefly about how these waves are going to interact. So what I want to talk about for a second is density. So if I have a wave that's traveling through rock, obviously that rock can have different kinds of densities. So let's just talk about low density versus high density. So if I have something that is really low density, what that means is the atoms that are in here are all spread out. So pretend those dots are atoms. So there's a lot of space in between those atoms, and that makes it very lightweight, essentially. If something has a high density, what that means is those atoms are packed in there much, much tighter. So there's not nearly as much space in between those atoms. So something that is a high density is definitely much more heavy. So let's think about what's going to happen to a wave as it passes through something low density versus high density. So if we have a seismic wave, and we're not going to get into the specifics right now between the 4 waves, so I'm just going to talk in generalities. If I have a seismic wave pass through something that's low density, it's going to be able, right, to come in, and when a wave comes in, it has to interact with each atom. So that wave's going to come in, and it's going to bounce off that first atom, and then it's going to hit the next one. But since there's so much space in between these atoms, it's going to slow the wave down, because that empty space is kind of like running through water. So it slows that wave down. So by the time the wave gets out of a low density object, the wave is slowed. Now, if we think about a high density, there's not a lot of space here in between these atoms. So it can just go through and bounce off really fast without losing much speed. Sometimes it'll actually move faster. So it was discovering this that helped us figure out the density of the Earth and where those layers are. So what we're going to see, and I'll show you on our next Let's Take a Moment, but what we're going to see here is, here's just some generic layers. Okay, let's say we have something that's low density, high density, high density, low density, high density. Let's say these are the layers. Now, I can't see into the Earth to see that that's what's going on, but I can tell by the speed of my wave. So if I have a wave comes in, and let's say everything that moves to the left is slow, and anything that moves to the right is fast. So let's say my wave comes in, and it hits something that's low density. So it's going to start to slow down. Now, as it hits our next unit, it is a much higher density, right? So our atoms are packed in there. Maybe it's more mafic. So my speed is going to, my wave is going to speed up. Now let's say I move into another high density, so it's going to go even faster. Now here I move into a layer that's low density, so it's going to slow down, and then high density. So this is actually what we use to define our layers. So like I said, we're going to talk about that in the next Show Me, the very specifics of each layer, because I think that's kind of important here. But I do want you to understand why we can use seismic waves and how it tells us the differences between the layers, because I believe that's important.